All right, today we're going to be solving network delay time. And basically, in this question, we're given a bunch of nodes that are directly connected to each other, and we have to find out what is the time it takes for the network to get from the start node, which in this case is going to be 2, all the way to the target node. But you can ignore the target node because we basically have to go to each node, so just the furthest node. It's a very confusing written question and it took me some time to get my head around it. Turns out I used Dijkstra's algorithm, and yeah, well, let's implement it. To start off, we have to make an adjacency list, which is I'll use the default dict because I want to initialize it to an empty list. And we could just import that right here. And then we have to populate the adjacency list. So we're just going to copy U, which is starting node, V, and W, which V is the node we're going to, and W is the weight it takes to get there, which is the one on the arrow over here, this one. In times, and we just want to say adjacency list on the starting node dot append, and we're just going to append the where we're going to and W, so the weight, and that should have the map that we want. From there we want to do a min heap, which is going to be empty array min map, trees as a heap, by the way, don't forget. Min map equals to initialize the min heap with 0 and starting node, which is given to us as k, and while min heap, so while something exists in min heap, we're gonna say time 2k, I can't spell, time 2k, and current equals to heap q heap pop. We pass in min heap in there, and if current in min map, we want to pop. Not pop continuing, basically, just skip that because it means there's already something, because the map's only going to contain the fastest way to get to each node, so we want to just skip that if the current's already in min map. Otherwise we add main map, and we're going to say current equals to yeah, so that's going to be time 2k. Actually, you should just take in time 2k. Time 2. Okay, because we should just have that, and we just have to get the max of that value. And yeah, we should loop through the adjacency list for current. So to do that, we're going to say adjacency list is going to contain these two things. So we're going to do like for v w in adj list, and we're going to say current so for VW in adjacency list current, we Hmm. Oh yeah, I do know what to do. We calculate the new time. We should be wait plus time to k. So that is so that we basically use the time we already have, and we get the new time, and we add both of them together. So every new time is just the sum of the whole time it takes to get to the actual node. And yeah, if v not in min map, we don't want v to be in min map, but if it is, that means we already have a minimum way to get to v, so we're just not gonna add, we're just not gonna do it. But if that's the case, we are gonna add to the min heap, actually, because it's a heap. We're gonna do heap queued, heap push, and that happens. I have no idea why. Min heap, and we just have to specify what we're putting in, which is the time is going to be new time, and the k is going to be v. And yeah, once that loop finishes running, min map should contain the fastest way to get to each node mapped to it, and we could just do if what do you call it, if min map or length of min map equals to n, return max of min map. That happens. This is so annoying. The values else we return -1. So if I haven't made any silly mistakes, I think this should do the trick. Let's run it and find out. And oh, I'm an idiot. Heap key the heap pop, and this is supposed to be a tuple. So hopefully it works now, and if we submit it, hopefully that's gonna work as well. And thank you. I'll see